Assalamualaikum. Hi everyone. We're about to start our event. So, second announcement. So, all participants, you may fill in and sign in your attendance, shared in the chat box. In the name of Allah, the most gracious and the most merciful. Assalamualaikum warahmatullahi ta'ala wabarakatuh, and a very good morning for those who are watching this from Malaysia and Philippines. The Honorable Associate Professor Dr. Saiful Kamaluddin Muzakir, Dean, Faculty of Industrial Sciences and Technology, University Malaysia Pahang. Dr. Azizan Ramli, Deputy Dean Research and Postgraduate Studies, Faculty of Industrial Sciences and Technology, University Malaysia Pahang. Dr. Fazli Farida Asras, Deputy Dean, Academic and Students Affairs, Faculty of Industrial Sciences and Technology, University Malaysia Pahang. Dr. Shamsul Zakaria, Head of Industrial Chemistry Program, Faculty of Industrial Sciences and Technology, University Malaysia Pahang. Associate Professor Dr. Lin Harold Lim, Director, Institute of Chemistry, University of Philippines, Diliman. Associate Professor Dr. Monisa Pederas, Deputy Director for Research and Extension, University of Philippines, Diliman. Professor Dr. Rio Lamorena Lim, Professor, Institute of Chemistry, University of Philippines, Diliman. Dr. Tay Ju Hui, Director, Coar 2023, Faculty of Industrial Sciences and Technology, University Malaysia Pahang. Faculty members, fellow students from UMP and UPD, and all the colloquium participants. Ladies and gentlemen, I'm Hidayah, will be your MC for today. On behalf of the organizer, we would like to welcome all the participants to the third Colloquium of Academic and Research Coar 2023. For your information, Coar 2023 is organized by Faculty of Industrial Sciences and Technology, University Malaysia Pahang, in collaboration with Institute of Chemistry, University of Philippines, Diliman. Without further ado, I would like to invite Dr. Teju Hui, Director Coar 2023. Please welcome her.
The Honorable Associate Professor Dr. Saiful Kamaluddin Muzakir, Dean for the Faculty of Industrial Sciences and Technology, Universiti Malaysia Pahang, Dr. Muhammad Fazli Farida Asras, Deputy Dean, Academic and Student Affairs, Faculty of Industrial Sciences and Technology, Universiti Malaysia Pahang, Dr. Azizan Ramli, Deputy Dean, Research and Postgrad Studies, Faculty of Industrial Sciences and Technology, Universiti Malaysia Pahang, Dr. Samsul Zakaria, Head of Industrial Chemistry Program, Faculty of Industrial Sciences and Technology, Universiti Malaysia Pahang, Associate Professor Dr. Len Harold Lim, Director of Institute of Chemistry, University of the Philippines, Diliman, Associate Professor Dr. Monisa Padres, Deputy Director for Research and Extension, Institute of Chemistry, University of the Philippines, Diliman, Professor Dr. Rio Lamorena Lim, Professor, Institute of Chemistry, University of Philippines, Diliman, Professor Dr. Ganti Pragasmaniam, Professor Dr. Muhammad Hasbi Ibrahim, Professor Dr. Chong Kwok Feng, and Associate Professor Dr. Hazrulizawati Abdul Hamid, the esteemed speakers from Faculty of Industrial Sciences and Technology, University Malaysia Pahang. Dear faculty members, lecturers, students, and participants from both University Malaysia Pahang and the University of the Philippines, Diliman. It is my great pleasure to welcome you all to the third Colloquium of Academic and Research, Coar 2023, jointly organized by the Faculty of Industrial Sciences and Technology, University Malaysia Pahang, and the Institute of Chemistry, University of the Philippines, Diliman. This is a special event that brings together scholars and researchers from various fields to engage in insightful discussion and share the latest findings. The theme of today's colloquium is Bridging Chemistry and Industrial Chemistry. This event is a unique opportunity for us to explore the ways in which the disciplines of chemistry can be applied in industry to advance scientific progress and benefit society. As we all know, chemistry is a fundamental science that plays an important role in our daily lives. From developing new materials to advancing medicines and healthcare, chemistry has the power to transform our world. However, the potential of chemistry can only be fully realized when it is integrated with industrial processes and technologies. This colloquium aims to bridge the gap between chemistry and industrial chemistry by bringing together experts from both University of the Philippines, Diliman, and also University Malaysia Pahang. We will hear from distinguished speakers who will share their experience and insights on the latest advancements in the field. I would like to express my gratitude to the organizing committee for their hard work and dedication in bringing us all together for this important event. Finally, I would like to thank each and every one of you for joining us today. Your participation and engagement are crucial to the success of this colloquium. With that, I wish you all a stimulating and productive colloquium. Thank you for being here with us today.
Thank you, Dr. T. Now, I would like to invite Associate Professor Dr. Lin Harold Lim, Director of Institute of Chemistry, University of Philippines, Diliman, to give a welcoming speech. Please welcome him.
Good morning. Can you hear me well? Thank you. Good morning, distinguished faculty of the Industrial Science at the University of Malaysia in Pahang, Dean Saiful Kalamuddin bin Musakir. Thank you for having us here today. I would like to acknowledge the early efforts of Deputy Dean for Research and Postgraduate Studies, Dr. Azizan bin Ramli, in reaching out to us to make this colloquium happen. Our participation in Coar 2023 is the product of initial talks meant to someday have a strong partnership between our institutions for the benefit of education and research. I am representing the Institute of Chemistry in the University of the Philippines of Diliman. It is one of the degree-granting institutions of the College of Science, and it is at the forefront of chemical research in the Philippines. It has a rich history dating back to 1910. Now, currently, our institute is made up of 25 senior faculty, 37 junior faculty, and 17 administrative and technical staff. We currently host several different high-end research, some of which are in collaboration with other local and international researchers. We cover research which include basic science, drug discovery and drug design, materials and energy research, spectroscopy and surface science, environmental management, computational chemistry, and scientific instrumentation. We try to evolve our expertise above and beyond our academic mandate, and we seek to connect with the larger scientific community. So this is an opportune event for us as well, so that we can reach out to more people internationally. And we hope that this event becomes the catalyst for the exchange of ideas and expertise that would someday benefit our researchers and students in the near future. We believe that the way forward in every endeavor, whether academic or otherwise, is the fusion of minds spanning different disciplines and cultures. So I invite you, young and mature minds in industrial science, to find applications that synergize with the chemical discipline. Let this be the start of an exciting future filled with possibilities in interdisciplinary research. Thank you.
Thank you, Dr. Lim. Ladies and gentlemen, now we will watch from Faculty of Industrial Sciences and Technology, Universiti Malaysia Pahang.
Established as a technical university in 2002, Universiti Malaysia Pahang UMP offers a variety of engineering and technology-based programs, including high-level technical and vocational education and training programs. Ranked as one of the best in research and innovation within the Malaysian Technical University Network and non-research university category, UMP is steadfastly committed to innovating and developing unique academic programs through strategic international collaborations. In the field of research, UMP collaborates with local industries to focus on industry-related applications. The Gambang campus is near to the East Coast Expressway, which is just a 30-kilometer drive from Kuantan, with an area of 126 acres and can accommodate up to 5,000 students. UMP students receive extensive exposure to the latest development in the fields of engineering and technology due to the geo-economic factor. The Faculty of Industrial Sciences and Technology offers 4 academic programs in the field of Applied Sciences. Bachelor of Applied Science in Industrial Chemistry with Honours. Bachelor of Applied Science in Industrial Biotechnology with Honours. Bachelor of Applied Science in Material Technology with Honours. And Bachelor of Occupational Safety and Health with Honours. In postgraduate studies, the faculty offers Master of Occupational Safety and Health in coursework mode and research mode in both master and PhD levels. Our faculty aims to carve a certain niche of clusters, which are advanced materials, green technology, occupational safety, health and environment, and drug discovery and diagnostic. Each cluster focuses on a different niche of area and field. The faculty offers courses in science and technology that are relevant to today's industry and to address the need for increased manpower requirements in science and technology. The faculty provides all the necessary facilities from outdoors to indoors activities, creating an environment conducive to learning for all our students. The facilities provided are to ensure our students gain the best of health and mentality throughout their studying period. The University Convocation is an annual celebration where graduating students receive their academic hoods and cross the stage to receive their degrees from the Chancellor in front of the University Senate, deans, faculty members, and family in the audience. Additionally, numerous prestigious awards such as Anugerah Pelajaran Diraja, Ingat Jaya Cemerlang are awarded to students that have shown outstanding achievements in academic, co-curricular activities, community engagements, industry engagements, sports and entrepreneurship activities. Our graduate employability index is in the range of 80% to 95%, with approximately 80% of employment in multinational companies. For undergraduate intake, the link provided is for local students and foreign students. For local students, the students can directly choose our programs via UPU Online, whereas foreign students can apply online using the following QR code. For international undergraduate students, the students can sign up at the following link or scan the QR code flashing on the screen. Fill in the registration and upload the related documents. Please visit our official portal, like our official Facebook, and follow our IG to get the latest info or scan the following QR code to know more. So what are you waiting for? Come join us today for a better tomorrow. Universiti Malaysia Pahang, Engineering, Technology, Creativity.
Ladies and gentlemen, now let us watch a montage from Institute of Chemistry, University of Philippines, Diliman. Dr. Lim, we cannot hear the sound.
Sorry, I forgot to I forgot to share it.
niya kumonekta sa dulo.
Ay, sorry.
Kaya pala may nag-clearing kanina pa. Pero kasi alam ko na kailan din
Sabi nakalagay.
wala naman nag-ano kami. Ha?
Petras nakalagay.
Nagkano nga kami dyan eh. May comwars kami sa org namin. Tapos nandiyan kami. Hindi ko na nakikita yung kipag last time ever. Pero sige baka makasila tuyo naman yung grass. Tuyo naman yung grass. Sobrang tuyo. Nandiyan naman tayo sa gate. Ba yan? Wala ka pala. Ngayon ko lang nakita ito.
Yeah.
Teka lang saan ba pwede? Sa physics naman, masyadong mainit.
Ano pala dito?
Sa math.
Ay, yung research.
Ito ang teaching building to your research.
And then yes,
Hindi talaga kitsutan ng feel ko.
Thank you for the montage. I hope that everyone can enjoy seeing the montage and can see all the facilities and also academic environment in UPD and UFP. Ladies and gentlemen, before we proceed to our next agenda, I would like to invite all the participants and guests to open your camera for photo session. Okay. Okay, stand by everyone. So have a big smile. So 1, 2, 3. Okay, again, 1, 2, 3. Okay, 1, 2. Okay, so thank you. Ladies and gentlemen, we'll start our colloquium. Before we start, I would like to announce that if there is any questions for the speaker, please type your questions on the chat box either in Microsoft Teams, YouTube, or Facebook. Any participant also may ask directly at the end of each speech where the microphone in Microsoft Teams will be unmuted. Also in the chat box, you may find the link for the attendance form. Please don't forget to fill in your attendance. All right, we will proceed our colloquium by inviting our first speaker for Coar 2023, Associate Professor Dr. Hazrul Rizawati Abdul Hamid from UMP, with her presentation entitled Analytical Laboratory Services in Chemistry Field, Importance and Challenges. Please welcome her.
Okay, thank you, Dr. Hidayah. So, good morning, everyone. I'm not sure in Philippines this morning or not. So, first of all, I would like to thank the organizer of this colloquium for inviting me for today's session. So, it's great to see all of you from UMP and also from University of Philippines, Diliman. So, thank you for joining us today. So, my name is Hazrul Rizawati I'm a lecturer and my field of research is natural products. As I seen in the video of Diliman introduction just now, there's a lot of facility available there. So it's good for sharing with us. And I'm also one of the person manage the central laboratory at UMP. So today I'm here to provide you some informations about the services available at the central laboratory UMP. So the topics regarding related to that labs is about the analytical laboratory services in chemistry field, importance and challenges. Can everyone see my slide?
Yes, Dr. Hazron.
Okay. So what is the importance of analytical lab service actually? So for all chemists, either we are in different field, organic, inorganic, analytical or physical, we still require analytical testing. So what is analytical testing? All chemists know this is a material testing, which is important for present day scientific studies and material production. So how this analytical service help us actually? So they have a optimal approach and methodologies within a lab environment. So analytical testing solve a numbers of unique challenges in complex focus area. So the principal purpose of systematic testing is to qualitative and quantitatively analyze our sample for characterization and classification. So what is the importance of this analytical service? So sometimes we don't have enough time to do by ourselves. Sometimes we have lacking of staff to do by ourselves. So that's why the analytical lab service is important for research actually, and also important for industry. So how does this technical precision help us to meet communication needs in critical field? So the first important is for the analytical services, it will provide the high technology testing. So for analytical chemistry, it's no exception to heighten the standard. So all the analytical lab service we have to achieve to the international standard. They will try to achieve as possible as they can for the international standard. So analytical lab exists to offer leading service that quickly and correctly classify, identify, analyze, and measure samples. For today's industry require reliability and rapidness. Not industry, we as researchers also we want a reliability and rapidness for a revolutionary result. So we want a very rapid result. So then that we can produce a good material and also a good research paper. So whether the sample will be preliminary for chemical formulation or for analyzed pharmaceuticals products, the ability to sensitively assess material with sophisticated instrument and equipment is the key. So analytical testing assists all different fields, biotech, food, environmental, and pharmaceutical companies that provide product to consumers for safety assurance and quality control. So the next point, which why the importance of analytical lab. For the second point, the analytical instruments and equipment solutions. Not all the institution or companies able to buy a high technology or all the instruments available for chemistry or material characterization. So analytical laboratory is the solution. So analytical laboratories utilize a wide range of instrument tools and technology. The varying articles, instruments, and equipment solutions that are available include content analyzer, thermal analyzer, chromatography, titrators, spectrometers, and other specialties. These incorporate mass spectrometry, microscopy, separation analysis, and hybrid technologies such as GCMS. So proper analysis allow for further method development and material enhancement. So we as a researcher and also the companies that develop product don't worry anymore about the method development because this analytical lab services will provide all these things for us. So the results of this analytical assessment and method analysis provide critical information on product potential impact. So the accurate determination of chemical and biological properties can save our life and change society for the better. So the next point, what is the importance of analytical lab service to support the industry innovation and also application? For the dedicated QC lab, so all the analytical lab service, we have their own QC lab with highly skilled staff. They have the person in charge for each instrument. So as we researcher, we keep on rotating to use different instrument. For analytical lab service, they are specialized for different instrument and for a long time. So if they're ready to provide high quality analytical support that we and also the companies required. So expert and experienced lab provide collaboration service. Other than they provide the technical service, they're also able to have a collaboration, which is a consultation service for a critical data insight. So studies and research project highly benefits from precise application of QC and analytical services. So offer an assortment of critical analytical lab service for GMP quality control measures. So pharmaceutical ICs especially, they really need required for the quality assurance and industry regulatory compliance. So for this field, pharmaceutical, food and environmental, there depends on the regulatory compliance that need to fulfill by different country. They have different regulatory. So goals for lab services. So the key objective for the labs, why we need the lab services for chemist identification. So ensure all the lab service we ensure they have a high throughput or productivity, and then they try to improve their service system efficiency, and they will develop a new service need by the organization. So the challenge while managing the lab analytical services, the first one, instrument maintenance and downtime. Sometimes they have environment facing increasing pressure to diminish costs while ensuring high quality service and safety. So what happened? While we try to provide a good service and to make it ready fast to release the result, sometimes the instrument will have a downtime, which is possible but impossible to release the results. And then how to maintain the instrument maintenance to be less cost. They need have a preventive maintenance program, which is it can reduce the repair cost, and then it will increase the lifetimes. And
ik heb dit op het web gevonden voor.
When we maintain the instruments in the good way, so it will produce accurate and reliable results. So maintenance is important for each analytical lab service. So the challenge too, which is turnaround time, which is sometimes we face the challenge. What is turnaround time? This is defined as time taken to complete a testing process, basically from the time sample is received for testing to the time is result. So mostly we as a chemist or we as a researcher or we from a company, we try to send sample to the lab service and then we expect to receive within 7 days or 10 days. So some challenge we cannot receive within that turnaround time. Why? Because sometimes the companies are not receive your payment. They will not starting characterize your sample. Definition turnaround time different. Sometimes people tend to receive in a very short time. They are not very patient enough. So sometimes the lab analyst cannot testing the sample because insufficient sample, and then sometimes what we hope to get the results we need to repeat. We didn't get the results, so in-house lab issue like equipment breakdown, reagent not enough, manpower sometimes have problems. There's a lot of challenge in the turnaround time. So the third issue will be the handling of sample or testing material. Once analytical lab service receive your samples, the quality of the lab activity depends on the quality of samples that have been received to be tested. So challenge for testing lab phase when it comes to the sample, sometimes the sample submit is incomplete or wrongly labeled, inappropriate sample preparation and or inadequate sample is received in broken or contaminated. So good lab service should have good lab management practice, sufficient resource to carry the functions, and samples flowing consistently in the lab systems, and good governance of public sector. So if all these elements have for the good lab service, so they will provide high quality of service, preparedness, and ensure the business continuity. Okay, so that's all for the challenges and the importance of the lab, the ethical lab service. For UMP, we have one lab which provide an ethical lab service to all researchers in UMP and outside UMP. If Philippines researcher interested to get the services from us or consultation from us, you may get through contact the Central Laboratory UMP. Our services included chromatography and spectroscopy, elemental laboratory, microscopic laboratory, environmental and GDP, and biotechnology laboratory. So all they have their own prices, and then you may contact us. And then this lab also have a recognition for international standard for the water and microbiology testing. So now we are offering the new service for 2023. We enlarge our scope for environmental water testing for the food samples and the soil samples. You may refer to our websites, or you may contact through our email, and you can see the news of Central Laboratory to our Facebook, and you may contact directly to the PIC of each services. So that's all from me. Hope to see you in the future. And then we also have a special offer, which is when you have a park grant or you have some money to get our service here for 5,000, you will get 10 free services, and you have extra grant that we're going to finish. You can park here and then you get our service. So that's all. This is the business model that might be offering to the universities and also to the outsiders. Okay, that's all from me, organizer. Thank you.
All right, so thank you very much, Dr. Hazrul, for the sharing. Now, I would like to open for any question from participant.
Looks like
you may type, or you may on your mic if you do have any question. All right, so we do have one question from YouTube. Okay, so what are the most challenging in lab services, Dr. Hazrul?
The most challenging is about the instrument breakdown. When you have not enough money, we pending the repair of the instrument, and then you unable to provide the services. So it will pending a few months, and then your business also will interrupted. So that's the main challenge, because instruments, when it goes a long times, it will oftenly break down. So that's the big challenge there, and the maintenance cost is very high. Okay, I think I'm answering the question. Any question?
Yes, any other question from participant? So if you do have any further question for Dr. Hazrul, you might directly go to her email, and also any details as mentioned by Dr. Hazrul, you may go to the website for Central Lab. So thank you very much again, Dr. Hazrul, for your sharing session.
Okay, nice to see all of you.
Thank you. Now, I would like to invite our second presenter. Before that, maybe Dr. Hazrul can unshare your slides. Okay, thank you. So now I would like to invite our second presenter, Associate Professor Dr. Monisa Pedres from UPD, with her title Institute of Chemistry's Graduate Academic Program. So please welcome her.
Hi, good morning, everyone. So can you see my slides now?
Yes, Doctor.
And can you hear me? Okay.
Yes, clear.
So I'm gonna share briefly our graduate academic program at the Institute of Chemistry at the University of the Philippines, Diliman. So before anything else, I would like to introduce myself. So I'm Melissa Pederes. So I'm the current Deputy Director for Extension and Research at the Institute of Chemistry. So the Institute of Chemistry is located at the National Science Complex. So this is the whole NSC. So the Institute of Chemistry is right here, or these are the two buildings. So this is the teaching building and the research building. So just a fun fact that the buildings, the shape of the buildings are patterned from the shape of the benzene ring. Okay, so currently we have 25 senior faculty, and then we have 37 junior faculty, or they are the lab instructors. And we also have 12 lecturers and 52 MS students and 12 PhD students who are currently enrolled this semester. So the senior faculty, so we have five academic groups at the Institute of Chemistry. So we have the analytical chem, organic chem, physical chem, inorganic, and then biochemistry. So currently we have six faculty at the analytical chemistry, and then we have five under organic chemistry, and then we have six physical chemistry faculty, and then we have five inorganic, and then we have three under biochemistry. So some of these faculty are also part of the other academic group. So their research interest or the research area. So for analytical chemistry, so we have organic, inorganic analytes, and then electrochemical, surface analytical, environmental chem, as well as chemical sensors. So for organic chemistry, so we have natural product chemistry, drug development, carbohydrates, as well as supramolecular chemistry. So for physical chemistry, so we have theoretical or molecular modeling, we have surface, interfacial, and then we have environmental as well as applied kinetics. And then for inorganic chem, so we have nanomaterials, we have the metal organic frameworks or the MOFs, zeolites, and then composites. And then for biochemistry, so we have theory and computation, we have proteomics, metabolomics, so as well as also natural product chemistry. So currently we are offering these graduate programs. So the MSc in chemistry and then PhD in chemistry. So we have the thesis option and then a non-thesis option for MSc in chemistry. And then we have three options for PhD in chemistry. So the third option here is by research. And these are the requirements. So for MS chemistry, so we require around 24 to 33 units of courses. It depends on which option to take. And then also 2 units of seminar. And then we have 6 units of MS thesis, and then we require, so for thesis option, so we require a defense of the MS thesis. And then for the non-thesis option, we require preliminary and then comprehensive examination. And then for PhD in chemistry, so the requirements are the following. So again, this depends on which option the student will take. So from 24 to 45 units of courses, and then 2 units of seminar, and then they also have need to take the qualifying exam. And then for PhD by research, so they need to take 12 units of dissertation, and they need to defend the dissertation. And as well as for the admission requirements, so these are pretty much the requirements in order to be admitted to PhD or MS in chemistry. So a BS or MS degree obtained from a recognized institution. So at least around 35 units of college chemistry and official transcripts, and around 2 to 3 recommendation letters. So we provide financial resources. So these are some of the financial resources for the graduate students or that they can apply to. So we have thesis grants. So these are from the University of the Philippines in Diliman and also from the UP system. And then we also provide, so from OIL Cooperate, so this is the Office of the International Linkages. So they also support students to go abroad and then do their thesis in international universities. So this is for around 6 months. And then they can also apply for a research grant, which is the ECWRG. So these are for the instructors. And also they can apply for scholarship. So this is from the Department of Science and Technology, and from CHED also, which is the Commission on Higher Education. So these are both scholarships. And then we also have the joint graduate program, or what we call as the sandwich program. So this is with international universities. Some examples. So this is basically so the student will go to other university and then conduct their thesis. So example of the universities that we have sandwich program or joint program are the University of Houston and Academia Sinica in Taiwan. So these are the facilities and equipment. So some of these were already shown in the montage earlier. So we have several equipment, and then we also have the analytical services labs at the Institute of Chemistry, wherein we also provide services both within the university and also outside the university. So pretty much this is all my presentation. So I would like to thank you for letting us share the academic program at the University of the Philippines. Thank you.
So thank you, Dr. Padres, for the sharing. Now I would like to open any questions from the participant. All right, we do have question in the chat box. So what is the length or duration for the master's program, Doctor?
So actually, it depends on the student, but now it can you can actually get the MS as early as maybe around 3 years. If the student is actually very very persistent, around maybe 2 years.
So minimum 2 years is allowable, is it?
Yeah. But the average, I think, is 3.
All right. Okay. So we do have another question from Dr. Fazil Fasihi. Hi, Doctor. I would like to ask about the financial resources. Is it only offered for local or international also can apply?
Well, I think if the international student is enrolled in the University of the Philippines, yeah, sure, they can also apply.
Okay. All right. So maybe any other question? So you may. Okay. Any question? Do you have question, Tachayani? Okay. So let me read the question in the chat box. Okay, from Koshavini. Hi, Doctor. I'm quite interested in know the drug development research. What kind of drug has been developed by UPDN? So
we have. Sorry. So we have several.
Yeah, sure.
So in terms of the drug development research, so we have several areas. So one is coming from terrestrial plants, and then marine science, and then other is synthetic drugs. So we test a lot of biological activities. So like currently, I think we've developed drugs on dengue, but that's from terrestrial plants. But we have several. We have several research that's ongoing. But we're trying to test a lot of biological activities right now.
So another question from Dr. Nazmi Kusaba. So are there any available postdoc position being offered at the university?
Well, at the Institute of Chemistry, currently, I don't think we have available postdoc, but with other department, I'm not really sure. But we don't offer a lot of postdoctoral positions here, actually.
Okay. So any other question? Quite interesting. There are a lot of questions.
Okay, thank you.
So I think that's all from the participant by now. So if you do have any question, you may directly go to Dr. Padras, of course, and also you may channel the committee for us to give to the Dr. Padras for any further question. So again, thank you very much, Dr. Padras, for this sharing. So now I would like to invite our third presenter, Professor Dr. Chong Kok Feng from UMP, with his title, Key Challenges for the Development of Sustainable Renewable Energy. So please welcome him.
Yeah, thank you, Dr. Hidayah. Yeah, sorry, I forgot to turn on my mic just now. You can hear me, Doctor? Hello?
Dr. Chang, are you there?
Yes, you can hear me?
Okay. Yeah, slightly lag. Okay, now quite
right
okay.
Now is it okay?
Okay, better, Prof.
Just hold on. Let me change the connection. Is it better right now?
Yes, better.
Okay, great. Okay, yeah, let me start with my presentation. Let me start sharing with my screen. Okay, I hope everyone can see my screen.
Yes.
Yeah, first of all, thank you very much for the invitation for me, the opportunity to share part of my research work on the energy storage device system. So today I'm going to share with you the metal oxide energy storage supercapacitor. So first of all, I would like to congratulate the joint collaboration between the UMP and University of Philippines, Diliman. So in organizing the third Colloquium of Academic and Research. So my name is Chong. So I'm working under Universiti Malaysia Pahang under Faculty of Industrial Sciences and Technology. So the topic of my sharing today will be the metal oxide energy storage supercapacitor. We start with the presentation of this smart city development plan. So if you look at the smart city development plan, so actually right now this is something that everyone is talking about. So whenever you want to design or develop city or people want to, the city they want to transform into the latest technology, so we cannot run away from this smart city planning. So in the smart city planning, we can divide into a lot of clusters like the smart home, smart health, smart building. So one of the key will be the smart energy, whereby if you look at the transportation right now, a lot of our internal combustion engine car so slowly being transformed into the electric vehicle. So in this case, the electric vehicle charging is something that which is very important. So if we look at this global electric vehicle sales, so we back into the 2021, the record was set that the highest record was achieved actually in the year of 2021. I believe that the data right now is still going up because right now people and all the countries actually they are slowly to move into the electric vehicle. So if we look at this the supply chain for this electric vehicle, so the most important or the core for this electric vehicle will be the battery itself. So it will make up from the traction of battery pack. So how this is a part whereby we store the energy in the electric vehicle. So whenever you are experiencing the decrease in terms of the energy storage in the battery, you need to go over to the charging port to charge it. So it depends on the country policy. So this is the part whereby if let's say in those countries whereby they are rich with this renewable power, so they might power up this charging port with the solar. So they are going to power up with the solar. But the main drawback for this solar powered electric vehicle charging port will be in terms of the energy storage, because you can't have the sunshine throughout 24 hours. So whenever there's no any sunshine, let's say at night, so you need to think of where you are going to store the energy that is being generated from the sunlight. So in this case, the battery or the energy storage device plays a very important role. And this is the part whereby trigger my research group to really investigate into the high energy storage device. And in this project, we call it is the quest for the high energy storage. So in general, we can divide the energy storage device into two. The first one is the battery, which is the conventional battery like the alkaline carbon battery, or the latest one with the lithium ion battery, or the nickel cadmium battery. Or the second part with the capacitor. So capacitor, so many of us didn't realize that actually capacitor has been used in our daily life so many times, just that it's not being widely spread out. So what's the difference between the capacitor and the battery? If we look at the mechanism for the capacitor, actually is made up from the material, whereby when you charge it, all the ions actually they will gather around the material. So whenever you need the battery, you need the energy. So all these ions will get released back into the circuit in terms of the electron, and then you can charge it up. You can power up your electrical devices. And all this charging and discharging process can happen within a very short time frame, 5 to 10 seconds. You can fully charge your supercapacitor, and within a very short time frame, you can release all the energy out. If we look at the supercapacitor market, so the market study has been done that up to 2027, the global market for this supercapacitor can go up to $15.9 billion. And supercapacitor has been known as one of the alternative energy storage device. It has high power density than the battery. It has a fast charging and discharging time. And theoretically, it has an infinite charging and discharging cycle. If we look at the examples that are in China, actually some of the bus actually they already powered up with the supercapacitor, whereby they can charge up for 30 seconds. So whereby they stop at one of the bus stations to pick up the passenger. Once they fully charge for 30 seconds, they can move for another 5 kilometers. And by using this concept, they are not using any diesel for their bus. If you look at the chart for this dragon plot, so actually this is something that all the researchers in the energy system that we are looking for. The energy density for the fuel cell is very high, means that it can store a lot of energy. But at the same time, it has a very low power density, means that you cannot release them out all at a very short time. Whereas for the capacitor, it has a very high power density, but at the same time, it has low energy density. So that's for the conventional capacitor. So the role for all the energy storage researchers, we are looking at this area whereby we want to develop a device whereby it has high energy density and has high power density. I use another analogy to look at how does the energy and the power look like. If you imagine that the capacitor, the conventional capacitor, you imagine that the small cup of water. So the amount of energy that can be stored, you can visualize as the energy can be stored, visualized as the water. When you need the water, you can pour them out at a very short time, but you need to fill it up, you can fill it out at a very fast rate. Whereas for the battery, you visualize the battery like the container for the water dispenser. When you need the energy, you can only release the energy through the very small hole. Means that you want to release the water, you can only release through this very small hole. When you want to refill it, you can only pass through this small hole as well. This has been used like the analogy that you can store a lot of water, means a lot of energy. But if you want to release the water out, you must go through a very small funnel over here. So our role is we want to devise a super capacitor whereby we want to enlarge our glass so that you can fill up a lot of water, and then at the same time that you can pour it out at a very fast rate. So what are those materials that have been used in the supercapacitor? So it can be divided into three types: the carbon base, the metal oxide base, and the conducting polymer. These are the three main materials that is currently under research to be used in the supercapacitor. So today I'm going to share with you on the metal oxide base. So what are the difference between the metal oxide base and the carbon base? If you look at the carbon base, the energy storage is only based on the absorption of the ion on the carbon surface. It can have a very high ion absorption, which leads to a high stability. But at the same time, it can only contribute a low energy density. Whereas in our topic, we are going to talk about the metal oxide. So the mechanism for the metal oxide in the past storage will be based on the redox reaction. The drawback for this, it has a lower stability as compared to carbon, but the benefit of this is has a high energy density, which meet with our target today. So this is to visualize what are the tests that we can run in order for us to test or to measure the performance of this material. We can run the cyclic watermetry, and we can run the touch-detach galvanometry as well, galvanostatic. So I go into our three of our project on this metal oxide. So I call this project as a quest for the high energy supercapacitor. So conventionally, the scientists are using the potassium hydroxide due to the high ionic mobility because it can move very fast between the two electrodes in the supercapacitor. And potassium hydroxide, if you want to really commercialize it, they have a problem whereby it has a corrosive nature. So that's why people turn into the sodium sulfate. The sodium sulfate itself is neutral, but at the same time, the performance is not as good as the potassium hydroxide. So in this case, we are throwing out the idea that we are going to use aluminum ions. The aluminum ions, because they are having a high ion capacity of +3, and at the same time, they have a very small radius. Small radius, which we can have the high charge capacity within one ion. So we are going to investigate what kind of material, the metal oxide, that can be used to capture this aluminum ion on the surface. First, we start off with the manganese oxide nanostructure. So for the manganese oxide, so you can synthesize the manganese oxide in terms of different dimensional, 3-dimensional. So we start to think of where can we get this manganese source. Then we start to look at those waste material, and then we studied it. In every piece of spent alkaline battery, actually it contains a 26% of this manganese oxide. If we just discard it, it's going to cause an environmental issue, and at the same time, we are losing our metal. So we perform the electrochemical treatment to recycle this manganese oxide. If you look at the cathode material, before the treatment, they are clumped together. But after we run through the electrochemical treatment, this manganese oxide can be formed in this, oxidized back into the manganese oxide in the nano flower shape. And then we run through the cyclic watermetry to check. So is it a very good performance in terms of charge storage? So for your information, the larger the area under the curve for the cyclic watermetry is to indicate that the higher charge storage. If we look at this after our treatment, it can really store a lot of charge. But this is only on the sodium sulfate electrolyte. Whereby we want to use it on the aluminum electrolyte. We try to use it on the aluminum electrolyte, but couldn't, because we look at the pore size of the crystal void for this manganese oxide, and then we find that is really couldn't trap because it's too big. The void for this is too big to trap this aluminum ion. Then we turn to another metal oxide, which is the cobalt oxide nanostructure. So for the cobalt oxide nanostructure, we form into the supercapacitor as well. Then we start to think of where can we get the cobalt. We look at other types of battery, the lithium-ion battery. For every piece of lithium-ion battery, actually it contains a cobalt because the lithium that we use in the lithium-ion battery is in the form of lithium cobalt oxide. So every piece of lithium-ion battery, it contains a high cobalt content, which is 20%. We run through the electrochemical treatment as well. In this case, we enhance it with the magnetic. We enhance it with the magnetic because the cobalt actually has a magnetic nature. And then we run through that, we see that actually it can form a very nice structure of this cobalt oxide. Again, we compare it without the magnetic field. We can see that we can form a very nice structure with this magnetic field. And we run the cyclic watermetry as well. We can get a very nice, very high charge storage. But we run through on this aluminum ion, it is proven that it couldn't because the aluminum ion is too big in order to get trapped inside this cobalt oxide structure. We can only get this high performance in the potassium hydroxide. So we do not succeed because we want to devise a metal oxide whereby it can trap the aluminum ion. So the last structure that we investigate will be the tungsten oxide. So tungsten oxide nanostructure, we can synthesize it by using hydrothermal method to get into the different morphology of this tungsten oxide. And in this case, we are not using any waste material because we're still searching where we can get this the tungsten. So we start with this chemical precursor, the tungsten chloride. Then under the hydrothermal process, we're able to get the tungsten 18049. So that's a monoclinic phase of this tungsten oxide. The morphology of this, we are able to get a very nice nano etching structure. Then we study the charge storage under different electrolyte. And it is proven that under the aluminum chloride electrolyte, we are able to store the very high charge, whereby most of the charge actually is in the diffusive nature. What does it mean? It means that right now, aluminum ion actually can diffuse within the structure of this tungsten oxide. Then we go and study the crystal void for this, and we find that actually it is really nice because the crystal void for this is a 3.8 angstrom, which is just nice to fit in the 3.75 angstrom for this aluminum ion. The specific capacitance, the charge storage is proven that is better than the rest of these because this is too high to get trapped inside. We run through the in situ XRD to really prove that the aluminum ion right now is really trapped during the charge and discharge process. And because of the performance of the previous one is not really good, we've tried to find out, is there any other way we can improve it? So we incorporate the graphene into the structure of this tungsten oxide. So during the synthesis process, we add in the graphene oxide. Then we can find it, all these tungsten oxide, they are successfully grown onto this graphene oxide sheet, reduced graphene oxide sheet. We also run through the cyclic voltammetry to check it. If you look at the graph over here, it's proven that with higher percentage of this graphene, actually we can cause a higher charge and specific capacitance. And the same thing, we run through the in situ XRD to prove that the aluminum ion is really get trapped inside this the crystal structure of this tungsten oxide. So what is the role of the graphene in this case? Why does it contribute to the higher charge storage? We can find it because, as I mentioned, this is due to the diffusive nature of the aluminum ion. It can diffuse faster, it can store higher charge. We run through the test to check on the diffusion coefficient of the aluminum ion within the crystal structure. And we show that with this graphene oxide added, the diffusion coefficient of this aluminum ion is increased up to about 18 or 19 times as compared to the tungsten oxide itself. So in this case, we can conclude that this fast aluminum ion diffusion is caused by the graphene oxide, and at the same time, aluminum ion can be trapped within the structure, the crystal structure of this tungsten oxide. And then we form into the real asymmetric supercapacitor device because we want to test the performance. You can check that, see that by incorporating one side with the tungsten oxide and graphene, we are able to get the energy density of 28.5. That's the highest among all the tungsten oxide material that has been reported so far. And it is also stable up to the 12,000th number of cycles that we keep on running the charging and discharging process. It is still maintain the retention up to 94%. So that's the end of my sharing. I will say that the quest is still continue. So all this result actually has been spread out, I think, within about 4 years to run this research work. So these are all the researchers that involved in my research group in order for the quest for this high energy storage supercapacitor. So with this, I end my presentation here. So thank you very much for your attention. So I'll pass back to you, Dr. Hidayah.
Okay, thank you very much, Prof. Chong, for the sharing on metal oxide energy storage capacitor. So very nice sharing. So we do have one question in the chat box. What steps can be taken to address the sustainability concerns surrounding the production and disposal of supercapacitors as a means of energy storage in the context of transitioning to a more sustainable energy system?
Okay, yeah, this is a very good question because right now, we are talking about circular economy, whereby all the material that we use, that we shouldn't create one, because the concept of this sustainable is you are able to recycle it. If you remember the 3R, the reduce, reuse, or the recycle. Okay, in this case, that for some parts that we couldn't reuse because we couldn't reduce it. Definitely that the energy that we need to use it for our daily life or for the advancement of technology society, we couldn't reduce it, and we couldn't reuse it because it's already the structure of it or the performance that couldn't really meet what we want. So there's no choice that we need to recycle it. So the concept of how to really achieve a very more sustainable energy system or sustainable society. So what we want to look at is all the raw material that we use should be coming from those. We shouldn't create one. We should look at those resources which is available in our nature, which is sustainable resources. For example, like if you look at the case whereby the first two research that I carry out, that we rely on the use of the spent alkaline battery, and the second one that we rely on the spent lithium-ion battery. So we hope that by recycling it, so we can really moving towards the sustainable. And the second thing will be, we want to devise if you look at the lithium-ion battery, the charging and discharging cycle can only last for roughly about 3,000 or 4,000 cycles. But with using all this, the latest technology of this supercapacitor, we're able to achieve up to the more than 10,000. That is also one way to really can prolong the operational life of this device. So in the sense of you do not discard it, because you can use it as compared to lithium-ion battery, 3,000 cycle. But on this supercapacitor, you can use up to about 10 or 20,000 cycles. I hope I answer your question.
Yes. Yeah, that's the best that we can do. So we hope that more recycling on batteries research on that can be concerned. So next question from Tachani. Hi, doctor. What safety considerations are important when using metal oxide supercapacitors, and how are these addressed?
Yes. I think this is very important regarding the safety. At the moment, if you are using the common like the cobalt, we never use up to the lithium, because when you are using the lithium, you need to really concern about the encapsulation of it. So that's the reason why you can see there's some explosion happen on some battery, because inside, so there's all this lithium, and they are using you cannot operate with the air, because most of the electrolyte that you're using is organic solvent. In order to achieve the high energy. So if you look at the research that I carry out, so we are trying to we are using the aqueous electrolyte, aluminum chloride in the aqueous electrolyte, so that we can achieve the similar performance as organic electrolyte. But at the same time, we do not really impose any safety issue, because when you do organic electrolyte, you need to really make sure that there's no any air or moisture being trapped. So that's why the encapsulation during the manufacturing of this is very important.
Yeah. So next question we do have from Nick Maisara. Hi, Dr. Chong. What are the major limitations of metal oxide-based supercapacitor?
Okay, I think the limitation is the how many times that we can use it. If you follow my slide, at the very beginning, we mentioned that the highest that we can achieve actually is infinite. Theoretically, it can have infinite charging and discharging. But when you're using metal oxide, we couldn't achieve the infinite, because it involved the chemical transformation. During the charging and discharging process, it involved the chemical transformation of this metal oxide. Whereas if we use a carbon base, there's no such because carbon is inert. But when you're using a carbon, you couldn't achieve the high energy. But you are using a metal oxide, you can achieve the high energy. But the limitation will be, I would say, that is the cycling life. So if you are using the carbon, you can have infinite, but using a metal oxide, we have the finite, which we cannot up to the unlimited, like the carbon.
Okay, thank you. So any other question from participant for Prof. Chong? I think there is no more question for Prof. Chong. So again, thank you very, very much for Prof. Chong for the very nice sharing.
Thank you.
And also thank you for all the questions given. Now, I would like to invite our fourth presenter, Professor Dr. Rio Lamorena Lim from UPD with her title Environmental Soil Chemistry Research. Since she's not able to be here today, therefore the organizer will share to you the pre-recorded video presentation of her.
Rio Bila Morena Lim. Good morning, everyone. I am Rio Bila Morena Lim, a faculty member at the Institute of Chemistry, University, and I teach analytical chemistry and physical chemistry. I used my interest in these courses in contributing to issues in environmental concerns. Malaysia and Philippines are similar in landscape, and so we both know that we are rich in many natural resources. And these resources have definitely are impactful to our economic growth. And proper management is really necessary in order to minimize environmental damage. I always ask my students to work or start with ideas, however small, so that we can contribute to the following areas at the national level. Okay, regulation enforcement, monitoring and risk assessment, disaster management, and policy making. These are big words, but we know that we will not contribute. Our work will not contribute immediately, but we know that we can contribute in the long term. So better start with small steps. All right. So one of our nice work is the use of laser-induced breakdown spectroscopy. This is an expensive equipment, but it's very easy to work with complex matrices. For example, soils and sediments. This analytical method is helpful in avoiding the use of strong acids like HF in preparing our soil and sediments. So we just dry our soil samples or sediment samples and then sieve it in a particular range, particle size range, and place it in a molder, and then prepare it as pellets, compact pellets. And then once we've prepared these pellets, we place this inside the stage of this equipment. And we use laser to irradiate the samples. And after several seconds, we can get a spectra of our sample. We can analyze many elements of interest using this equipment. So, for example, we can detect toxic metals from river sediment samples like chromium, copper, and lead. So we develop an analytical method to do this. And since we're dealing with complex matrices, we have to be particular with the binder we use when we prepare the pellets. So you can, because you work with such matrices, you can have a multitude of investigations regarding your binder. Okay. So, for example, in this study, we use a natural zeolite and compare it with the KBR binder. Okay. And then usually when you do analytical quantitative work, you have to generate calibration curves. So you can, with this technique, we can choose the univariate approach or the multivariate approach. So in this study, we first developed a procedure using the univariate approach. And once we were confident in using the analytical technique in determining target analytes, we develop a procedure using a multivariate approach. And then instead of just quantifying analytes, we move on developing equations or indices. Okay, so for example, in this work, we use our procedure in estimating enrichment factor and contamination factors, which are very important indices in the measurement of pollution level. Okay, a contamination factor of sediment samples obtained from selected mining sites. Okay. And we also applied our developed method in determining certain properties of soil. So we started with a simple idea, which is the cation exchange capacity. So we developed a model to estimate these values. My students were also involved in the mineral carbonation. I'm sorry, I couldn't see the title. Let me just move this a bit. Mineral carbonation of certain rock systems. This is the ophiolitic rock system or complex. These rocks are rich in magnesium and calcium silicates. And therefore, it's easy to react this with dissolved carbon dioxide. Okay. We studied the kinetic studies of the mineralization process. Okay. So we just use a simple setup, just use vials where we can react this rock samples with the dissolved carbon dioxide. Okay. And then after that, we analyze the extent of carbonation. For example, were we successful in the mineralization process using ICP-MS and XRD? So this is a nice project, and it's a potential geosequestration strategy to be applied in our country, because there are a lot of sites where we can sample ophiolitic rocks. Okay. It's across the archipelago. So doing investigation or studying the potential strategy is a very good idea. Okay. Of course, there will be some opposition, but if we share our work with the people, then they may be agreeable with this strategy in the reduction of carbon dioxide emissions into the atmosphere. and some of other small thesis work. For example, the estimation of pH buffer capacity of certain soil samples, okay? Because we want to, because there are some issues in certain areas in the country that the acidity or of the soil samples are not agreeable to the crop productivity of the area. So we want to know certain requirements in order to have better yields by improving the soil properties of the area. So her proposal is to determine the lime requirement in order to improve the productivity yield of corn in their province, in her province. And then another nice and simple idea from my student is the use of banana peel and then convert it into a biochar and then add it into a compost mixture in order to check if these biochar samples could improve again the soil property. In this case, by removing or absorbing metal contaminants from the soil sample. So example, he proposed that the banana peel could remove zinc and copper metals from the soil samples. Okay. And next is the proposal of another student where he tries to set up or fabricate a filtration system where he used these materials, activated charcoal, fish scales, fine sand, and pebbles. And instead of the conventional downward flow water filter system, he thinks that the opposite, okay, will be a better system to improve the water okay, by using this upward flow water filter. All right, and that's the last of my content. Okay, hopefully you've learned something from my students, from their small ideas. That's all. Thank you.
All right, so thank you very much, Prof. Lim, for the sharing. For the information, Prof. Lim is available here to answer any of question. So now I would like to open for any question from participant. All right, we do have question here. So how does the sensitivity and selectivity of LIPS compared to other analytical techniques such as atomic absorption spectroscopy or inductively coupled plasma mass spectrometry?
Hi, first of all, thank you for listening to my presentation. I am sorry that I would not be able to turn on my camera because right now I'm taking care of my toddler. Okay, he's sitting beside me. Okay.
Sure.
For the question, I would say that the sensitivity and selectivity of leaves is at the moment, I would say, comparable. That's why we kept on doing this experiments because I think ICP-MS is still superior in detecting these elements, especially these toxic metals. But because we want to address issues like disposal, chemical waste disposal after our experiments, then we have to shift to certain techniques that could help us to address these concerns. So I would say that LIBS is a like a screening method, and then if we are sure or confident that these toxic metals are present in our samples, then we proceed to the ICP MS analysis. So that's the way to explain it, because I agree that ICP-MS is still the better and appropriate analytical technique in determining these contaminants from environmental samples.
Okay. Right. So thank you for the answer. Any other question from participant? Okay, so any other question from participants? I think that's all for now. So thank you very much again, Prof. Lim, for your time here.
Again,
despite your busy schedule.
thank you.
So thank you. By the way, for all participants, if you do have question after this for Prof. Lim, so you may also write it in the chat box. So the organizer will collect and forward it directly to the Prof. Right? So thank you. All right, so we will continue our colloquium by inviting our fifth presenter, Professor Dr. Muhammad Hasbi Ibrahim from UMP with his title Vitrimus. So please welcome him.
Okay. Let me share my slide first. Boleh nampak slide? Can you see my slide?
Yes,
Prof. Okay. Thank you, Dr. Hidayah, your person for today. So also thanks you for our organizer, a friend from Philippines, and my colleague from UMP, Philip from FIS. So today I will share a little bit about Vitrimus. Vitrimus. I give what, 15 minutes, 10 minutes? Is that
Yes, 10 minutes.
10 minutes, okay. So we try to work out within 10 minutes. So it's been introduced by Dr. Hidayah. My name is Hasbi. Okay, I'm now working on a few projects. One of it is Vitrimus, whereby I will share a little bit today about this Vitrimus in how it support a circular economy. So our title is Vitrimus, a circular economy approach. So I will brief a little bit in terms of what is the Vitrimus, okay? What is Vitrimus and how it support a circular economy, whereby within the circular economy concept, it imposes to rethink the way a product is designed to be reused, repaired, remanufactured, and recycled. So it will introduce different approach. Is different with the previous concept, whereby it's very linear concept. This is where it close the loop and limiting intermediate disposal after their life cycle, with a positive impact on waste reduction and consumption of critical raw material. So we will support the sustainability issues, we support the SDGs concept and so on. So that's what we try to do with this Vitrimus. Okay. So now, when we're talking about polymers, normally there are two classifications, two groups, either thermoplastic or thermoset. That is conventional classification of polymer, and each classification, they have their own advantages and disadvantages. For example, we have the thermoplastic. It can be processed, reprocessable, okay, but it's not good in terms of mechanical properties, and also it's not compatible enough to resist in terms of contact with the solvent or high temperatures. Okay. On the other hand, we have a thermoset, whereby it's very good mechanical properties. They have very permanent cross-link characteristic, and they also able to resist most of the solvent, and at a certain temperature, they're able to resist high temperature. But the disadvantage is we cannot process or cannot we reprocess the thermoset. That's become a new concept of polymer, whereby early 2011 it introduced a new term. We call it Witrimer, to take care both issues and to come out with the best of both classification. Okay? So Witrimer actually it contains covalent adaptable networks, whereby it's different from permanent cross-link, for example, in the thermoset. So through covalent adaptable network, they can reverse or exchange at elevated temperatures. So those characteristic able to be Witrimer to be reprocessing. So it behaves like a thermoset, but can be reprocessed. It's very important to support a circular economy concept. And upon cooling after high temperature process, it can be shaped back to this what the characteristic that we want. Okay, next. In terms of to come out with the CAN characteristic to support a covalent intrinsic self-healing mechanism, there are a few approaches that can be used to produce Witrimers. And the basics, normally we can use trans-esterification reaction, and others also some introduced on this boron-based bond, imine bond. It depends on how we try to formulate our Witrimer characteristic. And those different approach is important. It depends on what's actually the final characteristic of Witrimer that you are looking for. Because when you produce Witrimers, we can use Witrimers for functionalization, advanced functionalization for different application. So we need to have a very specific character of that Witrimers to fit with the final application. That's why we need to choose a specific method to produce Witrimers. Okay. Then when we're talking about current Witrimers, normally they're based on non-renewable polymer backbones. For example, based on polystyrene, epoxy resin, or polyethylene, and so on. So still, even we try to talking about recyclable polymer, but still mainly based on non-renewable sources. So it's not fully support the circular economic concept or sustainable concept. Okay, so that's why one of our approach in our group, we try to produce Witrimer instead of non-renewable oil and gas based polymer. We try to base on bio sources or biomass. We try to leverage our abundance biomass to formulate a Witrimer, whereby this bio-based Witrimer also able to provide the right characteristic with the smart materials, the shape memory. It can be reprocessed, the self-healing, recycling, and so on. Right? The same characteristic as non-renewable Witrimers. This is important because we try to have the whole range is sustained. Okay, so bio-based feedstock for Witrimer synthesis to foster and promote sustainability. That's the spirit and the aim of this project. Now we're talking about this bio-based. It's numerous characteristic, numerous structure of a bio-based feedstock. It can be from cellulose. We can valorize cellulose to produce other fix ready for wheat synthesis, or we can base on the lignin, or we can base on others fix other feedstock. So we have different range of feedstock to produce wheat. So in our case, in Malaysia, for example, we have a lot of oil palm. So I just put a little bit here. What is scenario of oil palm industry whereby we can leverage those biomass to produce wheat. In this case, Malaysia is the second largest palm oil producer and exporter globally. So that will produce a lot of biomass. To support again the circular economy, the sustainability, it must be biomass valorization to be there. Okay. So we have about 5.74 million hectares overall. You can see here from this peninsula and also from the Borneo, we can have everywhere this palm oil industry. It's total about 451 palm oil mill. Okay, and through these industries, we talking about the produce about fresh fruit bunch about 115 million ton. And through that, we'll introduce a good GDP or revenue to Malaysia. And not again that the industry also provide more than 500,000 employees. So we cater in terms of employment. This with the additional about 250,000 is downstream also downstream workers. So this oil palm industry is very important because able to reduce poverty in Malaysia. We started from 50% in the 1960s, now about less than 5% today. It is very good. It's not only industrial based to purpose, but also able to reduce the poverty. Then oil palm industry count about 48% of total yearly biomass produced in Malaysia. But when we talking about a lot of biomass we produce, bear in mind that this palm oil industries is highly regulated by 15 law and regulation, and also support with ISO standard. Then also the players they sit to the round table of sustainable palm oil to make sure this industry not harmful to this environment and the ecosystem. Okay. So from here, a little bit brief. You have a palm oil. You can see they have this the neck. You have fruit bunch. You have trunk, front. Then what I try to see here, we have a lot of lignocellulosic biomass. We have an empty fruit bunch. We have the fibers. We have a front trunk that we can leverage to produce various materials and chemicals, including wheat. So that's what we try to have a big picture how our ecosystem in Malaysia able to be leveraged to produce highly tech and new generation of polymers. Okay, this actually this lignocellulosic biomass that you can wash everything. Okay, you can do fractionation. You can do either physical fractionation or chemical fractionation through solvent. You have the enzymatic, for example, you can use lacase or immobilized lacase, for example, to take out lignin, and also you can use a cellulase and so on. So in this case, for example, in our group, we have the lignocellulosic biomass. We do delignification, depolymerization. We take out lignin from this biomass of palm oil industries. We produce lignin. Then we also having cellulose part of this product. So they have two pathways now. So we will valorize lignin through lignin epoxidation to introduce epoxy group, bioepoxy. Then we will do next process cross-linking and so on to produce bio-vitamins. The another pathway is through cellulose. We have a cellulose now. We do a catalytic hydrogenation to produce bioethanol. Okay? Even if you not aim to proceed with the vitamins, you can use this bioethanol for different applications, including as a biofuel. So next, you can go to the dehydration from bioethanol produced, we can produce bioethylene. Ethylene again. Then again, ethylene is not proposed to the biovitamins. You can use ethylene for different application. Polymerization of ethylene will become bio-PE. This PE can be vitamization later on to produce biovitamins. That's the pathway. Along the way, the remaining or balance of cellulose that we have, we can hydrolyze. Either partial hydrolysis to produce cellulose nanocrystal, CNC, or you can fully hydrolyze to produce fermentable sugar for biofuel. So it can be a total solution to take care of those anything. And even when we produce CNC, you can put it into vitamins to increase the characteristic of the final product. Okay. And even if you not tend to produce high-end application, you can use this lignin for very straightforward application as an adhesive. Okay, this is actually the part of the project, our project with this European Commission, European funded under which project. So if you click VIT, actually we have a website, their website. Okay, so to end of my session, just put a key takeaway. So I introduced vitrimers, whereby this is a new generation of polymeric materials with high potential for multiple application in various industries. For example, you can include chromophore, that let's say oxygen sensitive material, or you can include what do you call it, light sensitive materials inside. Then when you put it all those signal material, it can be like a sensing inside the vitrimers. So it can be used for multiple applications like corrosion or optoelectronic applications, many more. So vitrimer is a platform polymers material for high-end application and able to support circular economy. And the beauty is because it retains the characteristic. You can reprocess and retain the required characteristic. And I believe that a close partnership with multiple research and industrial partner will mutually benefit researchers and communities. As I showed you previously, actually it's very big, it required integration of multiple partners with multiple expertise, multiple facilities, and also you need to have also industrial partner to join you at the beginning, so that whatever that we plan, that whatever we research, that we deliver, it fulfill the needs of the stakeholders. That's actually the most important, and we still able to generate science or to come up with the scientific finding through publication, and at the same time, we have a clear insight of the future for industrial benefit. Okay, that's it, Chairperson. Thank you.
So thank you very much, Prof. Hasbi, for the very good sharing. Okay, very up-to-date research. Okay, so we do have some question in the chat box. So first from Dr. Umaira. So Prof, how does the chemical composition of a vitrimer affect both its stability and speed of self-healing? And what are some of the trade-offs that must be considered when designing vitrimer materials for different applications?
Actually, because they have a CAN, covalent adaptable. That's one that you able to have the thermoset characteristic. But after certain, let's say you introduce stimuli, you stimulate, when you heat, it break down. But it still possesses the right characteristic. That's why how we control the CAN bond is very important for this particular vitrimers. Okay, but again, when we're talking about polymer, you need also to control many different characteristics. For example, if you try to embed certain functional material or certain chemical, you need to understand properly how it will behave. Either just blending or just you need the chemical interaction. So actually, it's have a huge potential to be explored in order to optimize. It is still new area, Chairperson.
Okay. So, if I could ask
Yes,
a little
please,
bit,
please.
maybe
Don't ask difficult question.
no. I just maybe Prof can share to us that what is the latest product or company that apply with trimmers, and maybe what is the limitation by now?
Okay, I said to you, now what we try to work on, optoelectronic, we try to do also for the insulating and so on. So they also pharmaceutical company. But the issue is now, how compatible your wet trimmers. For example, let's say, if we produce lignin-based wet trimmer, whereby the lignin color is darker, is it? Then if you integrate certain functional material, is it with the dark and with the light? What happened? For example, how the thickness? So still a lot we need to figure out. If you try to produce only the bare wet trimmer, no problem. But only bare wet trimmers, I can say it's not much high impact. You need to also for high end application, and those that there's still a lot of things that we need to figure out. They require both parties, materials, chemistry, or engineer to be there. Okay.
Okay. So next question. Hi, Dr. Wet trimmer seems to be useful product, but does it have negative impact to the environment?
Sorry again. Negative impact.
Yes, negative impact to the environment.
Roughly for now, how we synthesis and based on the feedstock is bio-based. First concept, feedstock must bio-based, not renewable. And second is can be recycled only with the heat. No need for the chemical and so on. That again will reduce amount of chemical involved. But the next to take care of the question, actually, we must do a complete life cycle analysis. We must carry out to make sure gate to gate of each process must be evaluate properly the life cycle analysis, how in terms of environment, how in terms of let's say in terms of cost, everything. So LCA analysis must be there. But brief answer, reduce a lot as compared to this normal polymer. And that's my brief answer.
Okay. So our last question here. What are some of the unique mechanical properties of wet trimmers, and how do they compare with other materials?
There, actually, you have very good mechanical, like a thermoset, very good mechanical, but reprocessable. That's actually the thing. Because no thermoplastic, it's not good. It's not also sustain at high temperature. So this is able to do it. And you can tune this the characteristic, and that's the beauty. Okay.
I think there is very lot of question for about wet trimmers.
Yeah. Personal message.
Stop here. Yes. Maybe Prof can answer in the chat box too.
Yeah. No. Okay. But please free also to you can anytime drop an email to me, then I can communicate properly, no problem. Because the chairperson, because I need to leave because I chair another meeting. So I cannot stay longer. Sorry for that. Sorry everyone. Okay.
Right.
Thank you.
Okay, so thank you very much, Prof. Hasbi, again for your time. And also thank you for all participants for very interesting questions, and looks like very interesting this topic. So very good, because this is quite relevant and latest information for us. All right, so now we will proceed our event. So I would like to invite our sixth presenter, Associate Professor Dr. Lin Harold Lim from UPD, with his title Enabling Local Aerosol Monitoring Capabilities in the Philippines. So please welcome him.
Morning. Let me just share that. All right. Can you see the slide?
Yes, yes.
Okay. Thank you. So, good morning, everyone. This is just going to be a bit quick. I've been doing some research that's a bit off from chemistry, which started off in 2013 and grew from that year on because of some requests. So it's about our journey towards enabling aerosol monitoring capabilities in the Philippines, and I'll just show you a bunch of things that put you in the background about this presentation. So first of all, I just want to familiarize everyone about aerosol research. So when we talk about aerosol research, we talk about particles. In some cases, we talk about particles in the air, which are referred to as particulate matter. So this can be anything from mineral dusts from soil or from concrete, soot and smoke from different exhaust of vehicles, including industry as well, and can also come up to fungi and viruses, including bacteria. So it actually became relevant back in the height of the pandemic. So these particles were in different sizes, the largest of which are 10 microns and above, which are referred to as PM10, PM2.5, which are 2.5 microns and below, and ultrafine particles, which are referred to as PM.1. These are the ones that get into the lungs and into the bloodstream. So in Metro Manila, just to give you an idea why this becomes important, the usual concentration in some places can go up to 100 micrograms of particulates per cubic meter. So supposing that an adult is around 60 kilograms and has a tidal volume of 500 ml. So the tidal volume is the volume of air that gets sucked into the lungs in one breathing. In a span of a day, so that would be like 26,000 breaths per day. So that person would probably breathe around 260 micrograms to 1.3 milligrams of particulate matter. Now that's, the number is small, but that kind of amount is already capable of sullying your shirt with the size of a palm. And so because this has become important recently in the Philippines, especially in Metro Manila, there are a lot of websites, in fact, a lot of initiatives from different groups, both public and private, on monitoring air quality in the Philippines. So there's a movement right now being initiated by the government as well, to have more sensors located in Metro Manila. So this is just one of those. This is from the sensors used by a gasoline station, which is, if I remember correctly, it's Uni Oil. And what you see here are, color-coded concentrations. So this was taken, in fact, around the same time there was an ease in the pandemic. So that's last year of April. So as you can see, Metro Manila looks kind of clean back then. I wouldn't suppose that it would be the same now. And so I've taken a look at our local area regarding the air quality. Apparently it's good, but there are situations, there are cases where it gets so high, like the ones in red, the ones you see in the minimap. The ones in red have concentrations are so high that are that make it difficult for people to sort of come out and spend a lot of time outside. And then there's also efforts on having this monitored periodically. And this is just one website, by the way. It's there are actually different ones out there. So In our case, what we wanted to do was, because aerosol monitoring equipment are actually very expensive. The units are expensive, their maintenance is expensive, their calibrations are expensive. So what we tried to do back in 2014 was to take a look at the cheapest possible method for monitoring air quality, and we identified this as the optical detection methods. And this uses the diffraction of light or scattering from particles when shown when illuminated by high density of light. So, of course, there are a lot of considerations to be done when it comes to these types of instruments. As you can see here, there's a diffraction limit of light. If any of you are into photography, you would know what this is. The instrumentation right now that are being used for optical detection methods officially, the ones that are for regulatory purposes, use what's called an air sheet. And it dilutes the air that comes in because the instruments are so sensitive that if run for a long while, it would get dirtier and harder to maintain. Also, there's some questions on molar absorptivity of particles. So this is the sort of the chemistry side of it, because not all particles would absorb and scatter light in the same way. And then there's the current instrumentation actually uses what's called a calibration curve for determining the size of the particles that get into the instruments. So there's sort of like a map between the intensity of scattering and the size of the particles that make that kind of scatter. So right now, the popular method for optical detection is what's called the principle behind it is called knee scattering, and that's how the current instrumentation out there, commercially, make a one-to-one mapping between size of particles and the scattering intensities. So this is what's actually used right now by most instruments to generate both concentration readouts and size readouts. Now, there are, of course, pros and cons about the use of optical methods. I'm just going to list a few. There are actually a lot of other methods out there. Like I said, the optical methods are the ones that are cheapest in terms of actual cost and operation. So the pros being is that, like I said, it's very inexpensive. There's little that you need to do and to work at. The components that are needed are very simple and sourceable. And it only requires low volume. So earlier I said that sometimes it even needs to be diluted because the optics inside the instruments are very sensitive to dust as well. The cons, of course, is that because scattering is very dependent on the absorptivity of the particles, there is a need for reference materials, unlike any of the other techniques. So in most cases, what happens is that there's a generalized refractive index that's used in the equations in knee scattering to sort of give an average characterization of the particles. So whether the particles are highly scattering or low scattering particles, they are sort of summarized or averaged out into a generalized refractive index. And like I said, because the optics operate on a very small illumination volume, it is actually very easy to saturate. So unlike the use of filters, which is the primary reference method, other optical methods and methods that do not require the use of filters are actually very easy to saturate. So, and there's also a limit in size detection, which again is because of the diffraction limit of light. Now, what we've come up with is something that we dubbed as ROAM, which initially was intended to be a robust optical aerosol monitor. This is our Facebook page when we tried to launch it in our, we made a social media blast around it. And the principle is actually very simple. And we're currently having it finalized in the patent. So instead of requiring the me scattering equation, we've actually done the detection explicitly using this camera. So it's sort of like a miniaturized microscope for air. So what you see here is an image of smoke by burning paper. This actually generates around particles around 1 micron and even smaller. And we are able to detect these particles, and so we are also able to count them. So in fact, just by doing some image analysis, we have come up with a very simple and effective measurement scheme. So it counts explicitly and then translates the particle count into concentration. The size selector, on the other hand, unlike current instrumentations that use me scattering, so instead of referencing a table for intensities related to particle sizes, we've just used a size selector so that only the sizes that are relevant to us are going to be counted. So right now it operates on PM 2.5. And though very simple, the technique is actually surprisingly efficient. So what you see here is what we tried as a sort of laboratory test. We call it the smoke diffusion test, and my associate actually tried to place a benchtop aerosol monitor, the TSI dust track, and together with Rome, so inside the box where there's initially some amount of smoke, and then we let smoke diffuse over time. And as you can see, just going through the small portion of the curve that is highlighted in red in a rectangular box over there, there's actually a high correlation coefficient of 0.9971. So it's almost our unit measures almost exactly like the TSI dust track. Although, of course, if we wanted to, we can easily extend the characterization up to really high concentration. So we're not as limited in saturation as most of the instrumentation out there. Although we chose to just look at the linear portion to make the measurements and the calibrations easier. And what you see here is our comparison with existing equipment from a government agency, our Environmental Management Bureau, Air Quality Division. They have what's called the Teledyne Optical Analyzer. And if you look it up, this is actually one of the equivalent methods specified by the US EPA. So we use that as a reference instrument. And so ours is the orange curve, whereas the blue curve is the reference equipment. And as you can see, just by looking at the temporal data, that we are actually very comparable, that we have been able to produce an instrument that's very comparable with a US EPA certified equipment. And below that, in the lower figure, we have a correlation curve between the two devices, Rome and the Teledyne Optical Analyzer. And we have a portion there where we have excellent correlation between the two devices. So, aside from that, of course, what we have observed during the course of the development of a device, so that's spanning several years already, and having contacted a lot of people regarding what they need for the device, we can actually get a lot more information about the particles compared to the regular me scattering based methodology. So it's possible for us to use information on the type of scatter, whether a particle is glassy or it's carbon, more graphene type, and we can determine size, of course, and these are all in the works. The movement of the particles is actually related to the sizes of the particles and not just in the equations having dependence on the densities. So what we're going to look at in the future is how well we can use image processing in order to determine size distribution of the particles and to relate the susceptibility to radiation, the scattering intensities into the general chemical composition of the particles. And furthermore, of course, what's exciting for me for this part is that a host of machine learning techniques can be applied exactly to extract hidden information that are normally ignored in contemporary optical devices. So image processing actually unfolds a lot of information if used in tandem with machine learning. And this is, the very small group that we had. It was the sort of the initiators of the project. So thank you very much for listening.
Thank you very much, Dr. Lim, for the sharing. Now I'd like to open for any question from participant. Okay, we do have question from Sharanya. Sorry. Hi, doctor. In Manila or Philippines, what are some of the most common types of aerosols that are monitored, and where do they come from?
Well, interestingly, we've actually been able to monitor a lot of different particles, but mostly we have concentrated, and this is because of the regulatory restrictions that are in place. We've monitored traffic pollution, which is in abundance in Metro Manila, and we have taken a look at the different situations, different places in Metro Manila, and there's also a project running alongside Rome, where we're trying to characterize those, and a lot of different information on how we can relate what type of particle is coming from where. So because they disperse very easily in the atmosphere. So, but it's mostly right now, mostly from pollution. So from roadside particles.
All right. So next, good morning, doctor. What are the properties or factors that will affect the accuracy of optical measurement in aerosol monitoring?
Well, right now, the one that affects it the most, and I think this is because it does so with any other methods, is humidity. So if we have a bit of condensation happening in ambient condition, some particles that are not of the size that we're looking for can actually still get in because water deposits on the particles. So in fact, that's the exciting part of it, is that the gross chemical composition of the particles actually determine how much water it can sort of absorb. But that's the most practical technical issue that we have right now.
Okay. All right. So any other question from participant? So by the way, doctor, your invention on the instrument itself, does it been used in specific area and applied in certain companies or environmental industry that interested in?
Yeah, actually, we're in a stage called a pre-commercialization stage. So we've already contacted different sectors who might be able, who might benefit from having this kind of instrumentation, because our instrument is much cheaper and it's much more portable than the ones that are used for regular monitoring of aerosol.
We do have a question here. Good morning, doctor. What instrument is the most accurate for aerosol measurements?
I would say the differential particle differential mobility particle sizers. So these machines actually use charges to determine both particle size and particle count. Although they are also the most expensive. So it's like buying a mass spectrometer just to monitor air. So, but those are the most, I think those are the most accurate instruments.
Okay. All right. So I think that's all from the participants. So thank you for all the questions. And of course, thank you so much, Dr. Lim, for your time.
Thank you for the time.
All right, so let's continue our event. Now I would like to invite our next presenter, Professor Dr. Ganti Pragasmaniam from UMP, with his title, Key Challenges for Development of Sustainable Renewable Energy. So please welcome him.
Thank you, Dr. Hidayah. Good morning, 11:55. Okay, good morning. Thank you, Dr. Hidayah. Thanks for the chance given to me to share my input in this session. I'm Gandhi, and my field of research will be biofuel and catalysis. Now, despite all the merits of renewable energy, right? I don't think that I need to go into it, the merits of renewable energy. But the statistic data shows that the world is relying heavily on fossil fuels, close to 80%. Now, this 80%, the numeral, the number is indicating the challenges or the practical challenges in practicing this renewable energy in a larger scale, right? Now, let us take a solar. What are the challenges, the key challenges in solar energy? Right, the efficient rate. Efficient rate is still low, right, comparatively. And the return of investment is a question in many regions. Weather dependency, right? It depends on the weather and the chemicals produced when we do the solar panels, right? When we manufacture the solar panel. Of course, it's a very clean energy comparatively, but before that, we need to produce these solar panels, right? So chemicals need to be used. And of course, as already mentioned by a few researchers before these presenters, right? The energy storage will be the issue, and the intensity of the solar are the key challenges, right? So in solar, right, implementation of solar as an energy source, right, in a bigger scale. Now, if you go to algae, right, algae, we can take what is that lipid from algae, and that lipid can be trans-esterified into biodiesel for the diesel engines. At the same time, the biomass from the algae, of course, it is a lot of nutritional values, but the biomass can be converted to bioethanol, right, to power all the petrol, right, vehicles, but not without challenges, right? We have yield as one of the major obstacles, harmful bloom, right, harmful bloom of other species, life cycle impacts when we cultivating this algae. We have to find out a very right species so that we can yield the maximum, right, output from that species. Now, CO2 supply, we have to continuously supply carbon dioxide, and of course the input costs in terms of the nutrient, right? Which species we have to select, which species can survive in the moderate conditions, right? So that we don't spend more on nutritional, right? The nutrient to cultivate this algae. So those are the challenges, right, with algae. And if you go to biofuel, right, biodiesel or bioethanol, right, in Malaysia that we have already implemented B7, right? B7 meaning that the 7% of biodiesel is already incorporated into our diesel, right? Our diesel vehicles in Malaysia, and I guess so in other regions, right? And bioethanol, right? And then what are the challenges from that will be the coal performance when we want to export our biodiesel to overseas, where cold climate regions, right? We have a coal performance. We have engine issues where it will be plugging, right, the filters of the engines. Storage stability, if not for months, at least for weeks, we need to keep that product before we can use or export to other countries. Catalyst is one of the expensive, right, aspect in trans-certification, that you need a very, what we'll call it, high performing catalyst, so that we can get a higher yield or right highest conversion. Now, as a byproduct, glycerol is a byproduct, and we have oversupply of that. It will destabilize the price in the market. And as all of you know, the feedstock cost is one of the major costs and a major concern, because we need abundant lipid, right? And usually we go for edible sources. Now the edible sources will have sparked this food for fuel crisis. So in order to cater that crisis, we need to go for inedible, right? Inedible source. When we go to inedible source, the abundant, the amount will be the issue, right? We don't get in a bigger scale or bigger amount. And if you want to use a waste oil, then the quality, right? The quality of the oil. So we need to use additional pretreatment to convert those cost-effective but lower quality oils. So those are the challenges. So all this renewable energy comes with a great challenges, right? And the incentives by the government. Okay. Now, if you go to wind is a renewable energy. We have issues of wind quality. Again, energy storage. We need to store because we don't get wind all the times, right? Then we have to have efficient energy storage. Then threat to wildlife, when we want to construct these wind turbines. Deforestation, right? We need to what we call it deforest. Okay, that is another issue of pollution and climate. And of course, the noise is another issue of this wind turbine. Now, somehow we already created energy demand due to urbanization, globalization, or industrialization, right? We already created energy demand, so it has been created, right? And not only that, when we already created energy demand, the associated carbon dioxide emissions already in the hike, right? It is rising. So we have two issues here. One is energy demand, not only that associated, right? Correspondingly, it will emit many gases and mainly the CO2. Now let us look back 1900, about 100 years ago. The world population is about 1.6 billion, right? In just 100 years, I can say that as about one generation, right? 100 years, we have expanded sixfold right, in a population. Now, with a rapid reproductive rate, right, the reproductive rate is growing, populations is growing, while the planet size is not growing, right? The planet size is fixed. So definitely we'll be facing insufficient in everything. Okay. Well, we are ready to have more people on planet, then accordingly we should be ready to reduce our needs, to share with those additional numbers. Right? Are we ready for that? Before we talk about the renewable or sustainable energy, are we ready to reduce our needs? Leave it to you to answer that. Now, sustainable energy looks like elusive. We all agree that scientists are doing their best to cater the needs of the planet. But for how long and at what degree of sustainability can the scientists work more and more? Probably they are just filling up the needs gap, but not in a sustainable manner. Just filling up and filling up with sustainable manner are two different things. If we live without this sustainability conscious, all the efforts by the scientists, researchers, or inventors will be a cosmetic development for very short term. Take this example, right? Our forefathers probably living in the most sustainable way than us. Let's say about 50-60 years ago, sustainability is part of their life. But now, after so many years of unsustainable practice, now we are talking or digging back again about sustainability. For example, they have this crop rotation where they rotate among the crops so that the nutrient in the soil will be remain, right? It won't deplete. And they never need any industrial made chemicals, right, to enhance the nutrient content in the soil. Now, after the practice already left, now we are facing soil nutrient depletion and of course end up in a lower yield. So one of the quick solution will be industrial made fertilizer, which readily creating energy demand and the associated pollution. Part of the world, and still they're using waste material for soil fertility, where the energy usage will be comparatively low. But with the need of the population, and probably we can plus with the need and greed, we want a fast crop maturity, we want extraordinary yield, and with that, we end up with no time for the soil to replenish. And no other way, we have to use industrial fertilizer, which can give you a short-term benefit, but in the long term, it reduces the soil fertility and the energy usage will be comparatively high, plus with the pollution, right? Then if we are already forced to use industrial fertilizer, right now the fertilizer price going to dictates that food price, and until it goes until good global food security concern. Before we going for sustainable renewable energy, as I asked before this, right? I mean, the world is asking us, or the planet is asking us, are we ready to reduce, right? In terms of food waste, in terms of traveling, right? In terms of our habit of buying, right? Buying things more than the need, and how we use this efficient energy at our homes. Even tourism, how to promote a sustainable tourism, reduce the carbon footprint, and creating campaigns, right, to celebrate that reduced or just fulfill the need, not the greed. What is our role then? Before we're going for sustainable renewable energy or sustainable energy, right? Are we ready to prevent waste food, rescue food? What is our role in the leftover food, right? Composting, food composting, right? And so on, right? And then are we ready to take a public transport, right? Even for short distance, we prefer to take cars. Are we ready for carpool? Reduce the need for long distance travel. Are we ready for that? Right. Those are the questions that we need to answer before we can talk about sustainability, sustainable in any aspect. Because as we've seen, the population is growing, ever growing, and whatever that we are enjoying, or whatever we are enduring now, never ever any generation before us can dream of. So if we've gone until that, it means a very rapid development technologically. So lifestyle has changed a lot, and until there's no room for sustainability. In short, the sustainable living means understanding how the lifestyle choices impact the world around us. Finding ways for everyone to live better and lighter. As I said, we need to ready to reduce things, right? A complete realization of sustainable renewable energy is very much dependent, right, on sustainable lifestyle. Now, I leave it to you to answer the challenges as what we have seen earlier, the technical challenges or technological challenges versus the lifestyle challenges. It seems like we are very much focused on technological challenges rather than the lifestyle challenges. We need to be focused on lifestyle challenges, the habits, the behavior, so that we minimize the use of natural resources and generation of the waste. Right. We need to think of what is that: reduce, reuse, recycle, and compost are the way forward. Thank you.
Thank you, Prof. Ganti. Thank you very much for the very good sharing. We might just focus on very advanced, technique and technologies, all the challenges to maintain and sustainable. So we have a question here. Good day, sir. May I ask what are the potential economic benefits of investing in renewable energy?
What are the potential economic benefits? That is low. Okay, when whatever countries are going to invest in renewable energy, it is forced to do that, right? Forced to do that because of the emissions, right? Right now, we can't see any economic benefit, but of course, right, in the pollution, in the minimizing emissions, we have a lot of benefits, right? Direct economical benefits are still a question because all the governments all around the world are subsidizing heavily on renewable energies. Maybe in long run we can get that, but bear in mind that the population growth. If we are stagnant, probably we can get the benefit, but if we are rapid growth of population, then direct economic benefit will be less.
Okay. Next is, good afternoon, Doctor. Biofuels production concerns the water quality. What's Doctor's opinion on this statement?
Biofuel, right? Water quality, yes, in whatever activities, water quality will be affected, right? Whatever, right? And then meaning that we need to be very cautious in all usage of all resources, not only in the biofuel. Biofuel particularly not going to give you a very big impact on water quality. Even without biofuel, we already have a lot of pollutions, right? Yeah, it's moderate. It's a moderate. It's not very high. Next question is what? Most promising types of renewable energy, is it? Dr. Raya.
Okay, actually there are
many.
Lots of yes. I need to choose question, but it's okay if Prof can answer one by one.
Okay, the most promising
transitioning to renewable energy.
Yeah, most promising types of renewable energy depends on the nation, right? Where they can get what is that for raw material for in a sustainable way. That will be the promising renewable energy for them. So for some countries like in Thailand, they are using this napier grass, right? It is in wild, they no need to fertilize it, and they harvest that, and they producing bioethanol. So for them, or for that village, or for that region, the napier grass bioethanol will be the best. So it depends on the geography and availability of this raw material in the most sustainable manner will decide which renewable energy will be best for that particular country. Why some
so it
do
relates
some
to the next question.
Yep.
The most promising types of renewable energy for Malaysia?
Yes, I said, let's say if you have a lot of palm oil and if there is any waste oil associated with that, and probably we can go into biodiesel, and with the sun intensity, we can go for solar, right? And also we are blessed with a coastal area, very long coastal area. No harm to trying in the wind. Yeah, depending on how it goes, the acceptance of the local community, the government policies will decide which renewable energy is the most suitable. But we are ready for quite a number of renewable energies. We are blessed with that. The renewable energy system brings negative effects.
Why do some countries?
Sorry,
Yes, Prof.
carry on.
It's okay. It's okay, Prof. You can just directly answer all the questions here.
Why do some countries not relying on sustainable energy? Yeah, they cannot do sustainable energy, not relying. They are not able to do that in a sustainable manner because of the problem that we said. Unless the global citizen can reduce, reuse, right, recycle and compose, probably we can go back to sustainable energy. There's nothing, it is not that easy shift to sustainable energy. It is a long process, and many factors are need to be factor into it. And there are many factors. It's not a very simple shift, just we can go sustainable energy. Like Malaysia, we cannot do biodiesel in a very bigger scale because palm oil is used as a food, right? Then there will be a food crisis, right? So we need to do it in a slower or acceptable manner. Okay, we cannot go just like that in ships. So yeah, there are challenges. So answer the question why some countries not relying on sustainable energy. There are many challenges that they need to address first before they can go for that sustainable energy. Renewable energy system being negative effect to our life and also environment. Yes, then what is that? Renewable energy system brings negative effect. Even without the renewable energy, you will have a lot of negative effect, right? We cannot particularly spell out that renewable energy will bring our negative effect. All the energy, whatever energy we venture into, it will have a negative effect, right? At some point, renewable energy can balance this emission, right? The pollution. So yeah, again, I said it is a very detailed study. How we do this renewable will be the answer, right? how much or what extent the negative effect is coming from that. But broadly, generally, the emission is very much controlled with renewable energy. How much does renewable energy contribute to climate change? Renewable energy, whatever energy will contribute to climate change if we don't do it in a sustainable way. Why we cannot do it in a sustainable way? We are unable to do that with a lot of challenges, as already spelled out, right? So all the energy will contribute somehow or other in different percentage to the climate change, but fossil fuel probably now we have seen more, right, to climate change than renewable. So renewable comparatively can be clean. May I ask out the listed most effective ways in slide just now? What Doctor's opinion, which is the most effective and why? Ask listed most effective ways. The best way, I leave it to you, because I already said we need to reduce. If you're ready to reduce food intake, right, no wastage, energy, water, even your leisure, right, your trip, your long trip, can you put on hold or reduce or minimize? That will be the answer, right? Because as I said, right, the population is increasing ever. So we need to do our part, right? The questions are good. All the questions are very relevant, but we need to do our part in order to answer those questions as a global citizen. We cannot rely on scientists. Are you sure you want to rely on only scientists? Scientists are trying, right? They are trying. So we need to rely on us, and with the help of scientists and technological, then we can move, right, forward. Think finished, right, the questions? Am I missed any?
I think that's all from the participants. There are lots and all answered. Thank you so much, Prof. And also thank you so much to all the participants, because it's quite interesting. So they are very near to themselves. They ask a lot. All right. So thank you again, Prof. Ganti, for your time.
Welcome, Prof. Doctor.
Without further delay, I would like to welcome our last presenter, Professor Dr. Imisu Martinez from UPD, with her title Electrochemical Studies of Ionic Liquids for Carbon Capture. Since she is not available today, the organizer will share her pre-recorded video presentation. While the organizer preparing for the pre-recorded version, if any of you have question, you can just type in the chat box and all the speakers can answer by time to time. So, okay, now we are ready. So let's hear from Professor Dr. Imisu Martinez on electrochemical studies of ionic liquids for carbon capture.
stems.
Sorry for the technical. Okay, let's technical team working on it again. So hope all the participants can wait for a bit. So for all participants, don't forget to fill in the attendance for your certificates.
Good afternoon, everyone. Thank you very much for giving us this opportunity to talk about our research interests in our group, particularly on the use of fat-based ionic liquids for carbon capture applications. Of course, I would like to thank the organizers of this particular activity. We have TVET Malaysia and then University of Malaysia, Pahang. Of course, our very own, the Institute of Chemistry, University of the Philippines, Diliman, and Dr. Manisa Paderes for inviting me to this particular colloquium. Our interest in ionic liquids stems from their unique properties, and I have actually listed them down here. So they're quite good, particularly for industrial applications in terms of gas solubility, because they have no significant that we are actually working on in the lab. And as far as we know, there's very little group working on these types of ionic liquids, probably because they're quite challenging to synthesize. However, in our group, we actually came up with a more benign way of synthesizing these ionic liquids compared to the normal way of preparing them, which is through electrofluorination. So we just follow the same typical steps. First would be the preparation of the chloride precursors, which I have shown here. And then the second step would be just an ion exchange. And like I said, this is more benign compared to the normal or usual electrochemical fluorination method, because you don't actually produce toxic compounds such as HF, phosphoric pyrophoric byproducts, and there's no OF2 that is produced during the synthesis. And it also circumvents the need for HPAP. And this particular process is actually very simple and easy to do. So this is how we prepare our sample. So we are working on characterizing the capabilities of these ionic liquids to solvate gases. So it's important actually that we're able to control the gases that we solvate into our ionic liquids. So this is our preparation setup. This is a high vacuum line that goes up to 10 to the minus 6 torr, and therefore we are able to control the gas that we put into our ionic liquid, and it actually comes with an RGA, or residual gas analyzer mass spectrometer. So we are actually quite aware of what are the volatile components present in the line, and therefore on the headspace of our ionic liquids. And of course, the next slides are just different experiments that we have done to characterize ionic liquids that we have synthesized. We start with the amount of water in our ionic liquids. So we use Carl-Fisher titration. And as you can see here, our values are quite low and comparable, of course, to known ionic liquids with known hydrophobic ionic liquids. And among the 3 ionic liquids that we have synthesized, the CN functionalized is the most hydrophilic one, probably, of course, because of the presence of the nitrile group. And then, of course, to determine that our ionic liquids are pure and there are no organic compounds dissolved in our ionic liquids, we also do absorbance measurements. And as you can see here, our ionic liquids are really quite colorless. And then, of course, we look at the viscosity of ionic liquids. We know that as you infuse gases into your ionic liquids, their viscosity will increase. So it's always good to start at low viscosity, to start with compounds with low viscosity. And then, as you can see here, we have actually determined viscosity versus temperature. And we have compared the 3 ionic liquids in terms of how their viscosity changes with temperature. And you can see here that, the nitrile functionalized one, once again, has the highest, probably because of the ion-ion symmetry or hydrogen bond disruption. And also, we think that we have lower viscosity for our methoxy functionalized ionic liquids due to the presence of this particular functional group, which actually lowers the energy barrier. And comparing, of course, the viscosity of our ionic liquids to other ionic liquids present out there, you can see here that they have comparable values. And then we also think that because we use a large anion, which is a FAP ion, it actually has higher free volumes, which lowers, of course, the viscosity. And then there's lower ion interaction, possibly between the two cation and ion, and higher mass transfer rate. And then in terms of the thermal stability, you can see here that the unfunctionalized ionic liquid is the most stable one. It's probably because of the saturated alkyl chain that's present. And then the lowest would be the methoxy functionalized one. And we think that it's because of the presence of an acidic terminal proton in the methoxy substituent, which led to its lower thermal stability. But compared to the other ionic liquids out there, you can see that our ionic liquids are quite stable. Of course, there's the TF2N ionic liquids, which are really very, very stable and as the highest among here, and we still have to beat that. And of course, in terms of electrochemical window, as you can see here, we have very wide electrochemical windows. In fact, the cyano-functionalized ones can really compare with this particular FAP ionic liquid that's also out there and not synthesized by our group. And we think that the reason for this very wide window is the anodic passivation due to the cyano group and, of course, stronger ionic interaction, once again, because of this functional group. And then using the same setup, our vacuum line, we perform controlled chronoamperometry to determine the amount of dissolved carbon dioxide in our ionic liquids. So to determine the amounts of carbon dioxide, we actually do 2 techniques. One is chronoamperometry, and the second one, which is the more acceptable technique, called the pressure drop method. And as you can see here, we've actually built most of the instruments in our lab. And these are our results. As you can see, these are the concentration of the carbon dioxide dissolved in our ionic liquids. And then these are the diffusion coefficients, which are really quite high and are actually quite very good. However, if you compare the concentration using chronoamperometry with the bulk concentration, you can see the very low amounts in our chronoamperometry measurements. This is probably because of the technique itself, wherein we actually only measure the amounts of carbon dioxides that are reduced on the electrode in our setup, as opposed to the actual measurement of the carbon dioxide dissolved into the bulk of the ionic liquid using pressure drop method. And this is the reason why it's good to always do two complementary techniques when performing an experiment. And these are the reason. This is what we think the reason is for the difference in concentration between electrochemical measurements and, of course, the bulk. Like I said, a reduction has to be done to measure the amount of carbon dioxide in the electrode. Therefore, we need to really find out. Measure in a way the radical anion generated in our electrodes, and this could lead to less reductive efficiency of our carbon dioxide in the ionic liquid, and of course the nature of the cation and anion affecting the double layer structure, which in turn of course affects how the electrochemical process measures the amount of carbon dioxide present on the surface of the electrode. And so for the pressure drop method, we also use this to determine the Henry's constants in our ionic liquids. And as you can see here, we get very good results. Of course, comparing it to the imid, you can still see that, imid is still higher, but in a way, we are getting very good values for our ionic liquids. And then we also perform IR spectroscopy just to see if there are really carbon dioxide in our ionic liquids. And as you can see, among the three ionic liquids, you can definitely see that carbon dioxide is present. So let me just summarize the work that we have done on this particular research work in the lab. So we were able to come up with a benign or environmentally preparation of our ionic liquids, and then the physical properties of our ionic liquids that we have, the FAP ionic liquids that we have synthesized in our labs are better than traditional ionic liquids present out there. But of course, we still have to do better than imid-based ionic liquids. And then in terms of their ability to dissolve carbon dioxide, we can see moderate abilities. And then we've also observed that the amount of carbon dioxide dissolved in our ionic liquids measured using chronoamperometric results are dependent on the electrode. And of course, this particular research really has a lot of promise in terms of carbon dioxide in electroreduction, which is very important in the industry. And so in terms of future work, we're thinking of synthesizing amine functionalized ionic liquids. Perhaps this will work better than the other ionic liquids because amines are normally used for carbon capture. And then at least for carbon dioxide solvation. And then what we're doing right now is actually using various electrodes in our chronoamperometric measurements and determining, apart from platinum, whether other electrodes are actually better at doing this. And of course, hopefully in the future, we will be able to perform SFG experiments on how ionic liquids are able to capture carbon dioxide from the headspace. And so with that, I would like to acknowledge my collaborators and of course, the students who actually worked very hard on this particular project in our group, Dwight Ruzon, and of course, Julius Dongson, who are no longer with us, but who actually went on to get a PhD in other groups. And of course, the person who's currently in my group working on the use of different electrodes for our chronoamperometric measurements is Carl Angelo Kaluwag. And so with that, I would like to thank all of you for listening. And once again, thank you very much for giving me this opportunity to talk about our work.
All right. So All right, so thank you, Prof. Martinez. Ladies and gentlemen, we are now at the end of our colloquium. On behalf of the organizer, we would like to thank to all our speakers and their very interesting sharing. To make this event more memorable, I would like to invite all the participants and guests to open your camera for the photo session. Okay, so we are ready to take a picture. So have a very big smile, everyone. Okay, 1, 2, 3. 1, 2, cheese. Okay, have another one. 1, 2, cheese. Okay. Maybe have some candidates. Right, done. Okay, last one. 1, 2, 3. All right, so thank you, everyone. So again, thank you for all the speakers and thank you all the participants for all the questions and attention. All right, so with that, Coar 2023 has come to the end. On behalf of the organizing committee, I would like to express my utmost gratitude to all our distinguished guests, colloquium participants for making this colloquium a success. I hope everyone is enjoying and getting benefits from this colloquium. So thank you very much. Terima kasih. Salamat. Till again, hanggang sa muli nating pangkakita. I hope that I pronounced it correctly. So thank you very much. Assalamualaikum warahmatullahi ta'ala wabarakatuh.
Thank you.
Thank you. Thank you.
Have a great afternoon.
Thank you, everyone.